Let us look at the tensors. First of all, it is to be defined. Suppose we look at writing a vector. Suppose I say a vector v, or in fact any other vector. Suppose say a vector. Okay, this we can write in terms of chronicle delta, something like this. Delta 1 and v1. This is a scalar quantity. So this is this there are two things. One is delta 1, that is chronicle delta, which is a vector quantity. We often call it as a unit vector. And v1 is the component of the vector v in direction 1. So this is a scalar quantity, right? This is a scalar quantity. So this is the notion. And but as it is, if I try to expand the vector quantity, so this is delta 1 v1, delta 2 v2 plus delta 3 v3. Okay. Similarly, here also it can be written. But coming to the tensor, the tensor quantities, its expansion in terms of its components, we need to expand. See, as we have seen, the expansion of vector in its terms, in the terms of its components. So this is a component, this is a component, this is a component. How is it tensor defined? Definition of a tensor: it is a quantity, it is a quantity that associates a scalar with each ordered pair of coordinate directions. I think a tensor. Okay, okay. Let us see a tensor. Notation of a tensor. Notation of tensor. Okay. See, generally, vector is given as v underscore the bar under the letter, or we can write vector like this, or we can write vector like this. So, but in some terms, writing a bar over the letter is little confusing. Suppose a tensor is denoted with tau, see tau. So, how do we understand whether it's tau? So, we can write a double lines at the bottom, or we can write a double lines at the top. So, let us assume writing double lines at the bottom. So, the tensor. So, the tensor as it is in terms of its components. How do I do it? In terms of its components. So the tensor, it is expanded like this. Delta 1, delta 1, tau 1. Tau 1 doesn't make a sense. So this should be 1. So delta 1, 1, 1 plus delta 1, delta 2, tau 1, 2 plus delta 1, delta 3, tau 1, 3. See now the terms, in the vector there is only one chronicle delta, but here there is a dyadic product. Okay. Again, let us see that what you call the definition is not complete. I am trying to write tensor in its terms of components. Next one is delta 2, delta 1, tau 2, 1. Delta 2, delta 2, tau 2, 2. Delta 2, delta 3, tau 2, 3. Last one, delta 3, delta 1 tau 3 1. See, I am just writing or defining tensor mathematically. Delta 3, delta 2, so delta 2 tau 3 2 plus delta 3, delta 3 tau 3 3. The second term, this is 2, delta 3 2, tau 3 2. So this is our scope. So in a generic form, how do we write this in a generic form? Tau is equal to, so I think there are, you can see in this vectors are available, everything is available. So I write sigma I is equal to 1 to 3 because we are referring to three directions. Sigma j is equal to 1 to 3 delta I delta j and the scalar quantity tau by j. So this is the total tensor we can write. Here delta I delta j put together, there is no multiplication symbol signs used in between them. This entire quantity is a dyadic product or dyadic vector. You can say dyadic, or by definition, what we can say as, no, this is a dyads or dyadic product only. We should not say dyadic vector, right? So we should say only dyadic product. Again, vector means this is actually a tensor. But as this we are referring to unit vectors, so we can call them as unit dyads. Okay, this is unit dyads. Okay, we'll see the properties of the unit dyads in the next lesson.